All right. Hey, everybody. Thanks for joining us. I think we're ready to kick it off. So yeah, I'm Paul. And today we have our Cassandra contributor call here with Jyothsna Konisa and Dinesh Joshi, of course. And they're going to be talking about CEP 34 mTLS based client and Internode authenticators. Just real quick before that, we get started on Thursday. We have our town hall and three kind of smaller speakers. So we'll have Scalable Objects Persistence V2, which is a project by Gerardo Recinto. We're gonna have our one of our Cassandra catalysts, Aaron Plutz, talking about Cassandra Corner, just a little behind the scenes and how that all works. And then we have State of Cassandra quarterly update with Josh McKenzie. So yeah, you should come check that out. That'll be on Thursday at 8 a.m. And that's all I have. So we'll pass everything off to Jyothsna.
Hi, everyone. My name is Jyothsna Konisa. I'm a software engineer at Apple. And we'll be co-presenting, Dinesh and I will be co-presenting today about CP34, which is Client and Internode mTLS authentication. Dinesh, do you want to take it forward? Do you want to get started?
Yeah. Thanks, Jyotsna. So, hey everybody, Dinesh Joshi. I'm a Cassandra committer and PMC member. I also am an engineering manager at Apple. So today we are talking about mutual TLS based authentication. Very quickly, I'll project the CEP that we've submitted, and it was accepted a while ago. So let's dive into the context of this. So mutual TLS is basically the usage of TLS certificates to authenticate a client. There are a couple places where Cassandra has authentication, where you use CQLSH or use the Cassandra driver. It goes through the native interface, and usually you pass in a username and password associated with a role or a user, and that is how we prove our identity. Now, there are a few drawbacks of using username and password. It's a shared secret. Although Cassandra has stores the passwords very securely, hashed and salted, all of that stuff, but still passwords are prone to leaks, and there are several drawbacks with password-based authentication. So what we are doing is we have introduced certificate-based authentication. Cassandra can, even today without this feature, use certificates to client certificates to authenticate the user, but it can only do it in conjunction with the username and password that is supplied by the user. However, what our CEP does is it completely replaces the passwords with a certificate. And therefore, when your workload is connecting to Cassandra, it is going to use a certificate, and we'll see how exactly. The other part of this work is the Internode protocol. So traditionally, the Internode protocol hasn't had any concrete authentication mechanism on it. Cassandra basically just uses the IP addresses to figure out like which of the nodes should be connected to it. So the Internode part was kind of soft as well. So what this CEP brings in is Internode authentication with certificates as well. So you could basically issue certificates to the cluster, and the Internode authenticator very much works similar to the client-based authentication, where it validates the identity of the incoming user, incoming node in this case, and authenticates the other node as well. So this is really useful because if you have infrastructure is deploying TLS client certificates, you can basically then use those for talking over Internode protocol, as well as to for the clients to talk to the Cassandra cluster as well. So mTLS raises the bar in terms of authentication authorization, but also enforces a secure channel of communication, because mTLS requires you to adopt TLS in the cluster as well. So that's the context, and we'll go through the implementation, but I would first dive into the demo so that it becomes a little bit more relatable. So Jyothsna, off to you for the demo.
Hey guys. Before going into the demo, I want to quickly talk about client identities. So when a client tries to connect to Cassandra cluster using a certificate, the mTLS authenticator tries to extract an identity out of the client certificate. And there's no particular format for this identity. An operator can choose to have their own identities. And in a minute, I'm going to show how to configure those identities. So for the demo, I'm going to be bringing up a Cassandra cluster using CCM, and I will be using mutual TLS with fallback authenticator. And I will create two users, one with the username and password, and the other one is going to be using a certificate to connect to Cassandra cluster. So yeah, so before starting the cluster, let me walk you through the configuration changes that one has to make in Cassandra.yaml in order to configure Cassandra with mutual TLS authenticator. So there is a section inside Cassandra.yaml called client encryption options. So this section deals with all the SSL related configurations required for client authentication. So if you look at it, so there's a field called key store and key store password. I'm configuring it with the key store, and then I'm configuring the trust store here, and then there is this field required client auth. So I'm making this as optional. So when I make this optional, Cassandra will accept both mTLS based and also password based connections. After this, I'm going to be configuring Authenticator in the Authenticator section of Cassandra.yaml. So if we look at it, here is the class name that I'm going to provide. This is going to be mutual TLS with fallback authenticator for this demo. And also there is this validator class name. So like I was saying, an operator can choose to have their own identity. For this demo, I'm going to be using a SPIFFE identity. That's why I'm using a SPIFFE certificate validator. Let me walk you through what we have in SPIFFE certificate validator. So if you look at here, there's a method called identity. This takes a client certificate and returns a string. So this has the logic of extracting SPIFFE out of a certificate. Likewise, if one wants to choose their own identity, they can simply implement this interface, which is mutual TLS certificate validator. And then they can configure that interface. They can configure that class in here. So, so that's it. Let me now start a Cassandra cluster. So before starting the cluster, let me actually show you the certificate that I'm going to be using for this demo. So here is the certificate. So if you look at the certificate, there is a SPIFFE that's embedded inside the certificate in the subject alternative name field of the certificate. So if someone wants to choose their own identity, they can do it by embedding some information in the certificate, or they can use some fields that are present in the certificate, something like a common name that we have in the certificate, or they can use a combination of multiple fields and they can create their identities. But for this demo, I'm going to be using this SPIFFE identity.
Just to add, or a little bit more context on what SPIFFEs are. SPIFFE is an open standard to describe a workload, or basically, what it allows you to do is, if you have a service, you can describe its identity in this common format called SPIFFE. And then that becomes the identity that Cassandra also understands using the classes that we have introduced. And if you have a different way of identifying your workloads, you can replace that class with something else, some other validator.
Right. Right. So this is a certificate that I'm going to be using. This is a self-signed certificate that I have generated for testing. So let me bring up the cluster now.
So
Here it is. Sorry.
once so the mechanism to adopting these mutual TLS identities requires you to have some certificates, some automation that allows you to get those certificates for all of your clients, and each of the client identities can be distinct depending on the number of clients that you are connecting or type of workload that you have. So each service can have a separate identity that maps to a user within Cassandra.
So now we have the cluster up and running. So I'm going to be connecting to this cluster with the admin user. So I'm going to be using SQL to do that. So now I have connected to the cluster, and I'm going to be showing you the current users of the cluster. So if you look at it, there's only one user, which is Cassandra. This is created by default, and it's a super user. And also I will show you identity to role table. So in this table, we store the role and its associated identity. So currently we don't have any identities added to it. So now I'm going to be connecting. Now I'm going to be connecting to this cluster using a user who's not currently there. It says provided username it's not there. And I will try to connect using an mTLS certificate. It says SPIFFE so-and-so. This identifier is not authorized. So what I will do is now I'm going to add the roles and add the identities into the tables. I have created a username password user, and I have created an mTLS user. And also I'm going to add the identity. I'm going to associate the identity to the mTLS user. So now if I look at roles, we can see the newly created users inside the table. And if you look at the identity to role table, now we can see the association. So now I'm going to reconnect to the cluster using the newly created password user. Now I'm able to connect to it. And also I'm connecting using the mTLS user. Now I'm able to connect to it as we have the roles and identities added to the tables. I'm going to quickly walk you through the SQL SHRC configurations that I have used. So this is the configuration I used for mTLS client. So here I'm specifying the host name, and then I'm specifying the port, and we have to make this SSL property to be true. And also there's a section called SSL wherein we can configure all the all the certificates required for client connection. So if you look at it, we have configured the root, we have configured the private key, and then we have configured the certificate. So this is the configuration that I was using for mTLS client. I'm also going to quickly show you a demo using Java driver. So I have two test cases here. One with one is a client trying to connect using mutual TLS, and the other one is trying to connect with username and password. So we have recently made this contribution to open source Java driver, wherein which we can pass in client certificates while connecting using mTLS. So if you look at here, this is the trust store that the client is using, and this is the key store that it's using. So I'm going to quickly run it. So we're able to connect using mTLS client. And this is with the password. So yeah, that's it with the demo. Let us know if you have any questions. Over to you, Dinesh.
Yeah, so just to unpack here, right? What was demoed here is that you can basically create a user with a password based authentication, and as well as a separate user which has a certificate based identity, and you can associate that identity to an existing role as well. And the more that Cassandra was currently running in was mutual TLS with a password fallback authenticator. And what that does is that allows you to plan for a transition where you have some users which are using password authentication, and then you want to onboard new users into your system that with mutual TLS certificate-based authentication. And this allows you to transition your existing cluster usage from password to mutual TLS. Now we can dive into the mechanics of the CEP as to how this is accomplished. But if in the interest of time, we can answer questions. I see at least one question. Jyothsna, the question is, the stored identity has to match the certificate's issuing domain. Is that correct?
It depends. Like if you choose your identity as your domain, then it should. But if you choose it to be something else, then it should match whatever.
Yeah. So to like do a little bit of a deep dive, right? The way client certificates, TLS certificates work are slightly different from the server TLS certificates. So when you get a client TLS certificate, that client TLS certificate can have the common fields, right? OU, which is the organization unit, and common name CN and all of that, right? And so you can use a combination of that field to validate the mapping between that certificate to your role within Cassandra, right? Or you could have something like subject alt name, which is embedded inside like a extension to the certificate that has the actual identity of the user that is trying to connect. So in a way, it depending on the certificate validator, if you're using Spiffy, Spiffy has a certain has a certain pattern, and you can derive the actual user's role from that Spiffy, and then map it to a role that exists. So it's customizable in that sense. And the way this authentication happens is not only does the netty layer, right? So when you're trying to connect to Cassandra, the netty listener that is listening to the incoming connections it's actually participating in the handshake, right? The client certificate is participating in the handshake. And so Netty will validate the incoming certificate, the client certificate that was provided, that it's not expired, that it matches let's say if the IP address is embedded inside the certificate, then it is matching the IP address that the request is coming from. So it actually does a lot of validation before it derives the identity and gives you the identity for validating within Cassandra. So there are all of these checks and balances that run. And so if you have a domain name that is embedded in the certificate, then yes, it will look up so it will look up the domain name and see if that domain is maps to the IP address that you're connecting from. So there are a bunch of checks that Netty will do before it reaches to the Cassandra's auth layer, authentication authorization layer, and that brings the additional layer of security, right? Somebody can't just carry a certificate from one host to another host. If you embed IP addresses, then you can just take the certificate from one host and copy it to another host and try to connect, because then Netty is going to validate and say, oh, the certificate seems to be valid, except that it's not coming from the IP address that is embedded in the certificate. So that gives you an additional layer of protection as well.
Awesome. I think if anybody else has a question, I think you can feel free to unmute and just ask directly if that's okay with you, Jyothsna and Dinesh.
Yeah. Sure.
Yeah, definitely. So while if there are no questions, I just wanted to quickly share my screen. A few things that wanted to call out in the CEP is there's a lot of information in here, but there are additional patches that have gone into the Cassandra Java driver. Now that is part of the open source Cassandra project. Those Jiras aren't linked off of here, but the other benefit, like we didn't talk much about the Internode authentication, but the CP does have information about the Internode authenticator as well. But the idea over here is fairly straightforward. It uses the same sort of identity class, and then you can list out all of the peers that are trusted, right? And one of the features that we introduced in this Internode Authenticator is that let's say we have a node that issued an identity, right? And it itself is one of the nodes in the cluster. So what the authenticator can do is you don't need to explicitly list out identities of every node in the cluster. What it will do is when the incoming connection is made by a peer, it will look up the peer's identity, try to derive the peer's identity, and it looks up its own identity, which is in its own trust store, key store, and then matches those two. And so if they belong to the same cluster, there is a matching phase in which you can match and say, okay, the identity that I've been issued is the same identity or a part of the same cluster that the peer is coming from, and therefore I'm going to auth, which is really cool, because now you don't need to explicitly specify all of the nodes in the cluster that should be participating in that cluster. So it kind of makes it completely automatic. At the same time, it will ensure that the authentication is done over the client certificates. And then the other piece that I wanted to call out is, depending on the frequency with which you update these certificates, you don't need to actually bounce the Cassandra process. What you will get is an automatic hot reloading of the certificate. So if the certificates change on the host, right, or the container that is hosting Cassandra, if it is issued new certificates, Cassandra automatically detects that change and reloads that in memory. So you don't need to do anything. It's completely hands-off. And that's true for the Java driver as well. The Java driver, once you make a connection, you're able to also hot reload the certificate so that you could use really short-lived certificates, 10-minute, 15-minute, or even shorter duration if your infrastructure supports it. That way the identity is constantly rotating, the certificate is rotating on your container, and Cassandra is not going to, don't need to bounce Cassandra or your application to talk to Cassandra.
Awesome. Yep. Are there any other questions from everybody else? Other than Patrick said he's super excited about this. So it's not a question, just a statement. But
yeah, I agree with Patrick that security is hard. This is one of the areas where I think Cassandra as a database has done well, but in today's day and age, things have changed. So using certificates, we want to make it as easy as possible within Cassandra. That if there are open standards, we try to add stuff that is based on open standards. SPIFFE is a fairly well-established standard in, I think, Kubernetes as well. So this can be paired well with Kubernetes.
okay, awesome. Well, I think if there's no other questions, I think we're a good place to end it. Yeah, so thanks for presenting. Really appreciate it, Jyothsna and Dinesh. And yeah, like I said, we'll be back on Thursday at 8 a.m. Pacific time for the town hall. So if you're there, just check it out. All
Thanks,
right.
everyone. Thank you.
Thanks for having us.
Yeah, of course. Thanks. Bye.
Bye.
Bye.